Welcome back, folks, to Scripting for Linguists. In this episode, I have this question for us. Is Rust by itself quicker than Rust called from Python with the PyO3 Rust crate or package when calculating the MATTR lexical diversity measure? MATTR stands for Moving Average Type to Token Ratio. And how about against Python by itself and Mojo and Julia? This is a follow-up question to my previous video in which I measured Python against Mojo, against Julia, and against Rust as called from Python. And surprisingly, I found that Python was quicker than Rust when Rust was called from Python to implement this moving average type to token ratio, which is a pretty simple algorithm. And what it is you take a 50-word window and you get the number of unique words divided by the number of running words, that is 50. And you do that for every last possible 50-word window sequence in the text. That is, you start with the first 50 words. That is from the first word through the 50th word. And then you, again, take the unique words divided by the running words, 50. And you hold on to that quotient. And then you move it one word to the right. So you're looking at the second word through the 51st word. You take the number of unique words divided by the number of running words, hold on to that quotient. Move it one word to the right, so you're looking at the third word through the 52nd word, et cetera, all the way to the end of the text. And then you just take the average of all those quotients. That's called the moving average type to token ratio, or MATTR, or MATTR, if you'd like. And I was surprised to see that Python was quicker than Rust called from Python. And so the natural follow-up question I had was, well, would Python by itself be quicker than Rust called from, would Rust be quicker by itself than Rust called from Python is, as called through the PyO3 package? So that is the purpose of this video, is to answer that question. And here is my native, I'll maybe call it native Rust, that is Rust by itself function here, get MATTR. You pass in a slice to a vector, and you have your window span of 50 words, and you just simply are moving the 50-word window one word at a time, giving the number of unique words divided by the number of running words. You take the average, that's it. So this is just a follow-up question, or a follow-up video from the previous video. So I've already run it before the video started, and we're going to be using the same results from the previous video, but we're going to add in native Rust, or Rust by itself. So this plot here is from that previous video, but I've added in the orange or yellow here is what I'll call native Rust, or Rust by itself. Again, the first take-home message is in blue here we have Mojo, and Mojo is super slow with this particular task. Mojo doesn't seem yet to be optimized for text processing. That's cool. I understand that. The modular team is focused on AI development and neural network machine learning, so that's cool. They're not yet focused on text processing. No problem. So let's actually zoom in, down in on the, let's zoom in, let's look at the points for a minute there. Let's zoom in on the bottom 4 lines here. In purple, the purple dots and purple lowest line, this is a locally based smoother line, or like a trend line, is Julia. The yellow or orange line is Rust by itself, which I call native Rust. The red line there is Rust called from Python with the PyO3 package. And then the green dots in line is Python by itself. So, interestingly, Rust called by itself, that is in the yellow or orange dots in here, are basically giving us the same times as Rust called from Python in red. Right? So these yellow or orange dots in line here basically on top of the red line and dots there. Except down here in the bottom left. The bottom left corner of this plot has something interesting going on. Let's zoom in on that corner. We zoom in on that left corner of the previous plot. We see here that these yellow lines, or yellow dots right there, are kind of above the red dots there. But down in the bottom left of this plot, down from 50 words in the text up to about 400 words in the text, the yellow lines there, or the yellow dots, are lower than all the other dots. So Rust by itself down there on the shortest text from like 400 words or fewer in the text actually is quicker, slightly quicker than Rust called from Python or Python. But at about 500 words, it jumps up. I don't know exactly what's going on here, but from about 500 words up to about 2,000 words, Rust by itself is actually slower than Rust called from Python. Not totally sure why. But at about 2,000 words in the text, they come back together and they just kind of go together for the rest of the test up to 10,000 words, like we saw in the previous plot. And that is interesting to me. So I don't know why that would be the case, why it kind of jumps up at 500 words there. Let's take a look. Let's take a look at that same plot without the dots for a second. If we just look at the lowest line, you can see that, yeah, interestingly enough, down here in the bottom left corner, Rust by itself is slightly slower than Rust called from Python. Not totally sure about that at the moment. Let's actually jump up to this main plot that is kind of a take-home message right in here. Let's turn off those lines, or turn off those dots for a second. So this is the whole gamut from 50 words up to 10,000 words. And you can see again that the yellow or orange line there is basically right on top of the red line. So again, the orange line is Rust by itself, and the red line is Rust called from Python with the PyO3 package. They're basically right on top of each other. And I don't understand exactly why Rust by itself with the lowest number of words is slightly slower than Rust called from Python. Not totally sure at the moment why that happened there. But the real take-home message is that Python is still quicker than both Rust by itself in yellow or orange and Rust called from Python in red. This green line, that is Python by itself, is faster or quicker than either of those two Rust lines there. That is a big take-home message here. That is the first time that Python has legitimately won a race against Rust and any of these other languages, Julia and Mojo. That is surprising to me because Rust is a systems level language. It's quick, has always won any benchmarking test I've had. Rust, go against any other language, including Python. But in this case, in this particular task of finding the moving average type to token ratio, Python is quicker than even native Rust by itself, as well as Rust called from Python. That is cool. Python has gotten quicker. I have a previous video also linked to in the description of this video, in which I looked at how Rust has gotten quicker over the last handful of releases, and it's supposed to get quicker in the future according to people that are writing in the blogosphere, right? Supposed to get quicker with future releases. So that's awesome. Python is quick in this particular task, and even quicker than Rust, which is surprising to me. So there you have it. Let's answer our questions. Go back to our question: is Rust by itself quicker than Rust called from Python with PyO3 when calculating the MATTR lexical diversity measure? No, it's not. It's basically right on top of itself. And so I'm wondering if the overhead, my thought is perhaps the overhead of having Python call Rust is pretty limited, and it gets kind of like swallowed up the more words you put in. Like the quicker, it's just a quick overhead, not a big overhead. And it's just kind of swallowed up into the time it takes for the actual algorithm to run. So that's what I'm wondering, if the overhead is not as big as I thought it would be to have Python call Rust. And how about against Python, Mojo, and Julia? Well, Python by itself, working by itself, was actually quicker than Rust working by itself with this particular task. So yeah, I'm concluding more and more that when people say, oh, Python is slow in comparison to whatever other language you want to throw at it, including Rust, I am now saying, okay, but what benchmarking task are you basing that statement on? Because with corpus linguistic methodology, like the stuff I do on this playlist, Python is awesome. Python's quick. Rust has been quicker with some tasks, but in this particular task, Python was quicker. Go Python. Go Python team. You guys are awesome. So there you have it. Python is awesome. Rust is awesome. And Rust was not any quicker than by itself than having Python call Rust with this particular task. So there you go. You learn something new every day, right? That's what good research is about, answering questions and having follow-up questions. Anyway, thanks for watching. Don't forget to like, comment, subscribe, all that good stuff. Thanks. See you next time.